Hey everyone, welcome to this podcast. I'm joined here by Pete Kaneski from Belden, and we're really excited to talk to you today about scaling Industry 4.0 and smart manufacturing use cases using connected plant. This podcast actually is accompanying an ebook that is being published by Belden, focused on scaling Industry 4.0 pilots and why most Industry 4.0 pilots fail to scale. Pete, why don't you introduce yourself and your role at Belden?
Sure. Thanks, Ed. Thanks for having me on today as well. Pete Kineski, within Belden, I'm a solution consultant based on the East Coast and been with Belden just over 10 years. And as a solution consultant within Belden, my job primarily is to work hand in hand with our customers on evaluating their current platforms as it comes to their OT infrastructure, to control system architecture related to OT networking, how those systems look, how cyber secure they may be, as well as look for areas to help them improve on different things like overall equipment effectiveness or production capacity, and using Belden solutions both in house and through our partners to help deploy what those improvements might be. So it's kind of like the nuts and bolts, if you will.
Thank you for that. I think your background and experience is super relevant to this call. I'm excited to learn from you and get into our topics. And for those out there, I'm Sid Gambier. I'm part of Accenture's Cloud First organization, and I focus on building Industry 4.0 solutions with our partners like AWS and even Belden. So, Pete, as we start here, why don't you describe the current landscape that you see as a solution consultant when you're talking to your customers, Belden's customers today? What are some of the business challenges that folks are facing? These are plant operations people, plant managers, VP of operations among manufacturing companies. What are you seeing out there?
Oh, it's a big question, in fact, Sid, because there's probably a lot more problems than there are solutions at this point, right? If you ask enough people. So one thing to consider as well is that within my expertise, though I dabble in a lot of different markets and work with our customers on, I'm mainly focused in the consumer packaged goods market. So I deal a lot with CPG related customers. And as you may or may not be aware, CPG is a very heavily competitive business, just like a lot of others. And to stay competitive, most CPG type manufacturers, whether you're manufacturing soap or perhaps even toilet paper, or perhaps it's just cleaning detergent, right? There's plenty of competitive landscape out there. So what we're seeing in the market is this transition of them wanting to be more quicker to the market with the delivery of their goods, and how do they achieve that? So, and there's lots of ways that they're trying to. One of those ways that's probably the most popular, as you mentioned, is Industry 4.0. The more digitized, the more smart they are with their assets and production capabilities, the quicker and more efficient their production becomes, and hence they can deliver more goods to the market that way. So that's probably one of the biggest things. And then I guess probably the second biggest highlight would be that in today's time, there's probably a lot of discussions around workforce shortage, right? It wasn't long ago that I did a seminar where I went over kind of a detail of what that workforce shortage looks like. So if you're a company that's lacking operators, that you're lacking personnel to work in the facility, what does that mean? And how do you keep machines running? Well, you have to automate at that point, right? So the way to assist a lack of a workforce is to make sure the machines are able to give you the information you need, so you can make intelligent decisions on how to improve processes.
I see. So I really heard two or three things there. A lot of the manufacturers, especially in the consumer goods space, are challenged with operational agility. Cost is a major component of how they run their operations. Of course, in the last couple of years, we had supply chain challenges because of the pandemic that somehow seem to be easing up now. However, the talent shortage and skills shortage is a real constraint that CPG manufacturers face today. Is that fair to say?
Absolutely. In fact, there's probably an aging workforce as well in there, right? It's not so much the lack of new help, but an aging workforce is probably more of a concern. And you have people getting up there in age, and who comes in to replace them? Who's there to train those replacements? If you have people retiring, things along those lines, so it becomes a real big issue. And there's plenty of studies that talk about that, and that's a big thing we talk about with our customers. Is one of the biggest advantages to moving towards this 4.0 digitization is to help alleviate some of those pain points.
I see. I've always believed that rolling out and scaling up a technology solution is as much or perhaps less about the technology, and it's more about the users and the people that are using that technology, the pain points they are solving, and really empowering the human element in the manufacturing context with Industry 4.0, things like industrial IoT, machine learning, and artificial intelligence. Talk a little bit about, if you put yourself in the shoes of a plant operator, you're walking the shop floor in a manufacturing context. What does that environment look like? What do you see when you look at a variety of different assets, different machines? The challenge of making this Industry 4.0 technology work and work well in a manufacturing plant. What are some of the main pain points that customers come to you for?
Say I'm putting myself to your question in the shoes of, let's say, a plant operator, right? And one of those pain points I would see as a plant operator is that, let's say, for instance, I'm working a machine, working an HMI, understanding human machine interface, and I'm operating the process according to how I'm trained, things like that. And the machine happens to stop or fail, so on and so forth, right? Now, what I would do normally is I would have to then first reach out to maintenance, right? And how do I reach maintenance, right? Is it a phone call? Is it an email? Is there a work order system? Things along those lines. Does that even exist? And me as an operator, as you mentioned, the human element is, well, the machine fails. Does that mean I report the failure right away? Does anyone else know it failed? Does the next piece of the process care that my machine failed? Like, so what does that look like? Do I go take my 15-minute break? I mean, and then come back and then report it then? So it's a lot of this variable accountability when it comes to these type of like micro stops and machine stops. And so it's about automating and holding the right people accountable, and understanding that production must go on.
Okay. So let's move forward and talk about the role that a connected plant can play in improving uptime and improving availability of the assets on the floor. What do you see in terms of companies, Belden as well as your customers, executing pilots or projects to implement connected plant initiatives?
I would say probably the first thing that comes to mind is, first, I like the idea of pilots, right? Of course, I do. There's a couple things to be said about pilots just in general. I've often seen pilots done on specific machines, which is okay. But the need for that pilot is a little bit smaller in scale. And what I mean by that is the pilot that's done is to achieve a very harsh problem as quick as possible to get it done and get it deployed. But by doing that, and sometimes it's hard because sometimes it's a rush type thing and you got to get it done, and I understand that. But the idea is that if you're going to do a pilot, you really want to have the capability at least to look a little bigger, right? So the solution you provide in that pilot for that machine, that portion of the plant or that process line, whatever have you, you kind of want to think about it from a much larger scale. So what you deploy there doesn't pigeonhole yourself into something that you've deployed and you can't replicate elsewhere. Because the idea of a connected plant is to be able to use scalable solutions so that you're not constantly creating a new uh, uh, cookie cutter for every single process line, right? You want all your cookie cutters to be the same, at least as best you can.
Yeah, agreed. I think that really resonates with some some of the successful pilots I have seen work, where the focus isn't so much on a particular machine or a particular asset, but how do we extract data, or how do we connect different types of assets that are a little bit representative of what we have in multiple plants, not just in one plant. So we're building on the learnings. We can achieve an element of repeatability. Scale really comes from taking the same solution and repeating it in either across a plant, across multiple cells, or across multiple plants. So I see that as one aspect. You mentioned that as well. The other aspect that I see critical in how pilots should be designed, and perhaps this is a missing piece for me, oftentimes pilots are designed in such a way that they are just proving out a particular technology, or for lack of a better phrase, they are designed to be a technical feasibility study only. What I recommend, and what we see companies that do this industry 4.0, these initiatives really well, they approach pilots as a proof of value. You know, they think about their OEE in the plant, either the labor expenses associated with that OEE or machine uptime for the same labor footprint, or the throughput of the machine. And the pilot is done in such a way that there is a business case, there is a value case behind that pilot, so that when the technology is successful, you're actually able to measure, and you're able to compare to the baseline of what did we achieve in terms of dollar value, either savings in raw materials, or for the same labor expenses we're able to get more throughput or things of that nature. So I think a proof of value is equally important. Would you concur with that, and have you seen proof of value as part of successful pilots?
I would say it's a requirement for a successful pilot. We will typically not start any type of pilot work without first building the value case of what that pilot's going to achieve. I think it's the probably most important thing to look at. So, but have I seen other pilots done without the use of that? Of course. But I would always say that when you're done with a pilot, your best gauge of success is looking at the hypothesis, which is kind of the value statement ahead of time of like an ROI, right? What's the return on this investment? How do I realize it? And even then, when we end up deploying some of like our data engineering services and evaluations of certain processes that we do for our customers, typically we're always developing some type of ROI based on very intricate math calculations and letting our customers kind of use that as a gauge to see, well, maybe they think by doing this piece of the process as a pilot, they're going to get the most ROI. But during our evaluation, we determined that no, 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 this bottleneck you have earlier on, we feel based on these numbers, this math is going to give you the best return on investment. It's worth looking at, these type of things.
I think those are some wonderful lessons learned. So, if I just repeat back what I heard, you're recommending looking at the entirety of a manufacturing process, understanding where bottlenecks may occur, and then really targeting an Industry 4.0 connected plant pilot to a value case behind the OEE that corresponds to that particular subset of the manufacturing plant.
Exactly right. Exactly right.
Talk a little bit about your experience where you've seen the other side of the coin, where pilots do fail either because they haven't included the human element, or there is no value case, whatever the reason may be. What are the consequences of that? So for our listeners out there, when manufacturing companies are thinking about executing industry 4.0 pilots, what's the cost of failure here, of not being able to scale a pilot?
It becomes trial and error. So you have all kinds of costs introduced when you do a pilot. Of course, you have the human time element. So there's that. There's pieces of equipment. There's parts. So there's you can tie basically monetary value to pretty much everything that goes into a pilot. Mostly, it's going to be time and resource, right? Because it's people's time is essentially the most monetized aspect probably of anything during a pilot. So to kind of have that happen, not only is it just the monetized value of people's time, but it's also if you look at the systems that were put in place that didn't solve the problem, right, are now systems that may still yet stay in place, not helping the problem, but just kind of existing. And at that point, the company could just kind of keep it in place running. And who knows that if it was a failed pilot, whether or not that ends up causing some further issues down the line or things along those lines. So there's no telling, but definitely the human element and human time and energy is probably the most costly for a failed pilot.
There's an opportunity cost. You're asking people that really their day jobs are keeping a plant running, either doing maintenance on the equipment or whatever their job may be within that plant. You're asking them to spend time on doing this additional pilot or initiative. There's a opportunity cost to that. There's probably a lack of desire to innovate and to try new things. If there is a failure, that, oh, we spent all this effort in doing this pilot 6 months ago, it didn't lead us anywhere, so why should we believe this next thing? What would be the advantages, right? If you're able to scale a pilot, we all know the promise of Industry 4.0. Going back a few minutes when you talked about the talent challenges, the talent shortages, what would be the advantage of, what would it take to bring together the right set of capabilities in order to scale a pilot? What do you see at Belden and with your customers that maybe is the missing piece?
I'm gonna try to not get too technical, but it might require a little bit of technical. So, and that's me as a background. So we'll try it that way. So, uh, the biggest thing with a connected plant 4.0 and a lot of these industry terms is data, right? It's all dependent on data. So you want to talk about workforce shortage, you want to talk about pilots on certain machines, everything's driving towards a data collection, premise, right? And one of the key elements of that is how do we get data? How do we get the right data? And what I say is even more critical is how do we contextualize that data? Because the contextualization of that data is what's key. Because sometimes, and again, when you talk about scaling, right, if you need to contextualize data for one specific machine, one specific process, and the mechanisms and methods you use to do the contextualization are specific and built for that process and not scalable, now when you do the next machine, the next process, the next facility, right? Because that may be the trajectory you're after. Now you're deploying yet a different contextualization method for that data, right? And when I say contextualization, what I mean is there's plenty of data points on any machine, whether that's through data points the PLC is getting through tags, whether that's through IO link, whether that's through other types of technologies and mechanisms. How you get that raw IO data and contextualize it. There's many different platforms on the market today that will do one specific thing for one specific type of data, right? So if you want to contextualize Ethernet IP, that's one thing. If you want to contextualize Profinet, that's a different thing. It's another driver, it's another this, it's another software. And then you get that data contextualized, and now you have to integrate it into different systems. So if you want to integrate it into CMMS or you want to integrate it into an MES platform of some kind, now you have to have yet another piece of software that's another driver, that's another thing, and that could be a different MES or CMMS across different facilities, even. So every time you do it, It's going to end up being something unique that someone needs to get trained on to be able to support it. And what Belden is doing is really what they've done is built a contextualization engine that is meant for many, many disparate sources of data. Whether you're in Europe and you're using Siemens Profinet, whether you're in America and you're an Allen Bradley Ethernet IP control system, maybe you're in South America where Modicon is very popular and you're using Schneider Electric, or maybe it's in Asia Pacific where it's very heavy Mitsubishi based, right? So if you have plants all over the world and you're looking to deploy large scale connected environments where everything's contextualized and integrated using one single platform, that's what Belden's in the business of providing our customers today with in-house solutions that we have at Belden.
Excellent. So the key thing is visibility of different types of data from different machines, different PLCs, and contextualizing this wide variety of OT data in such a way that you can extract the intelligence from this data. You can analyze it easily, and that's where Belden really comes into play. Also, providing a unified, converged network infrastructure in the plant with different vintages of machines and different vintages of PLCs and assets, that you could have a common rail, if you will, for all these different types of data to come into a single platform where you could run machine learning based analysis, you could build analytics. That's really the key to doing this right.
Correct.
There is a wonderful story at a historic plant, Belden's Richmond plant, that we should get into at this point. What was the problem there? How did Belden go about solving that problem, and what can we learn from that story?
Yeah, it's actually quite impressive. And you think of like a 70-year-old facility, right? And surely, Belden themselves is not even the only ones. I mean, there's certain factories out there that are even older than that, right? That have still been up and running and had things added and subtracted to the plant over the years. And speaking in that same vein, when it comes to even my position within Belden, is that OT network infrastructure piece is a very, very large piece of it. And speaking of our wire and cable plant, that was one of the first things we do during the evaluation period is look at, are we talking about islands of automation, right? Because the first thing you think of with a connected plant is, well, I have to connect the plant first. And so, within Belden's in-house solutions, we're able to help our customers analyze what may or may not be already set and ready to go to a 4.0 digitized connected plant and what may not be, and be able to develop and design what the path forward may be with our capabilities. So, and that plant was no different, right? We had machines that were not even Ethernet, right? They're still running on old serial bus protocols, so plenty of device net, control net. Some machines are newer, so they have some Ethernet connectivity, but nothing is really being monitored outside of just the operator running the machine
That's right.
and providing their end product that they need to provide. So it was really about evaluating what was already there, taking those older legacy systems, right, using our in house solutions to provide a way to get those legacy systems into a more industry 4.0 domain by basically connecting them to Ethernet infrastructures, connecting the individual machines together for the connected plant aspect. So it's ready for that data collection, contextualization, and then the integration of that contextualized data into MES platforms or ERP to help realize a bottom line.
So, network infrastructure that makes it easy to integrate with different types of machines, get different types of data all in one source. So, you have better data visibility of how the assets being used and the performance. And then, what was the end result of that improved data visibility? how did the operator's life improve based on the improved data visibility at the Richmond plant?
Well, at the operator level, the operator now has an engine of intelligence being able to feed them. So a micro stop or a machine failure, right? The time in which an operator would have to go normally diagnose what that problem is, right? We have already, if it even gets to that point, because in that plant with the predictive maintenance measures we put in place, the operator can have intellectual data as to when a potential part may be failing, perhaps weeks if not months ahead of when it's possibly going to fail. And so the operator can already put in kind of work orders to have that part or that piece or that equipment replaced during scheduled downtime. So again, the end results, based on even the initial calculations for what we think our ROI is going to be, is somewhere upwards of eight to $900,000 in overall equipment effectiveness saved on the bottom line. It was not small by any means, and definitely outweighed, met the value that we first looked at when we were first evaluating.
That's wonderful. Thank you for sharing that story with us and our viewers and our listeners. For me, I think the part I loved most about that story was in terms of the technology that was implemented for improved data visibility and the connected plant. There was maybe nothing much groundbreaking about that technology, but the way it was done, Belden used its internal resources, its own solutions, included the human element, built a business case, a proof of value around that pilot to improve machine uptime and to create, I would even say, a sense of ownership among the plant operators who already take a lot of pride in their work, but perhaps they see there is investments being made in the plant, new technologies coming in, and they are energized by it. I mean, did you see that impact among the plant operators as well?
Yeah, it's good to bring up that human element part, right? Because that does play a big role into it. The ease that an operations manager and the operators themselves will feel on that, because the amount of pain they would go through during that industry 3.0 type practice, right? Where evaluate what happened, what's wrong. Maybe the operator has a KPI that's associated with that machine's productivity, so suddenly now they sense this anxiety, right, on making sure everything's running, and to be able to help alleviate some of that anxiety, right, just as the human element alone, by giving them some intellectual data that helps that machine run smoother to improve their KPI, so they feel happier at the end of the day and more productive. I mean, that goes unsaid. I think, it's just, or shouldn't go unsaid, I should say.
Wonderful. I think we've covered a lot in this last few minutes in this discussion, right? We talked about the challenges faced by manufacturers out there from a talent perspective, supply chain perspective, and really wanting operational agility. We talked about why most pilots are doomed to fail because they're focused too narrowly, or maybe there isn't a business case associated with that pilot, and really embracing the human element in the plant as a way to success. I really appreciate it, and I got a lot out of you sharing the story at the Richmond plant. I think it's a great example of Belden really looking hard at their own manufacturing, thinking about the solutions that Belden offers to their customers, but then saying, how can we use what we make today to actually improve our own operations? Peter, I really can't thank you enough for your insights and your time, and I'm confident that our viewers and our listeners have gotten a lot out of this conversation today over the last few minutes. As a parting note, I will again encourage our listeners and our viewers to check out the ebook that is available on belden.com for deeper insights into scaling issues and how to scale Industry 4.0 initiatives, and engage with Belden, Pete, and others, going to belden.com and really letting your thoughts be known on what resonated, what makes sense, and what you would like to hear from us in the future. So, with that, Pete, I once again thank you very much for your expertise, for your time, and sharing all of that with us today. And I thank our listeners and our viewers for tuning in, and hope to see you all very, very soon. So, Peter, thanks.
My pleasure, Sid. Thanks for having me.
Of course, anytime. Bye.